Welcome to This Explainer. Today, we're diving deep into the fascinating and honestly, sometimes gritty world of minerals. We're going to track them all the way from your completely mundane morning routine, right back to the dark depths of the Earth's crust. By explaining the core concepts of this chapter, we are going to truly unpack and understand the hidden materials and energy that quite literally power our entire modern civilization.
Here is our roadmap for today's explainer. First, minerals in daily life. Second, what exactly are minerals? Third, the hidden costs of mining. Fourth, conserving our mineral wealth. And finally, 5, shifting to renewable energy. Let's get into it.
Section 1. Minerals in daily life. Let's kick things off by looking at how totally, utterly dependent we are on minerals, starting the very second we wake up.
So, have you ever stopped to wonder what exactly makes your toothpaste sparkle? Or, for that matter, how it effectively cleans your teeth? We usually think of minerals as these distant, abstract things pulled out of a mountain somewhere, right? But the truth is, you're quite literally brushing your teeth with rocks every single morning.
Yeah, the answer is an entire geological recipe sitting right there on your toothbrush. You've got abrasive minerals like silica and limestone, which do the actual physical cleaning. Then a mineral called fluorite provides that cavity-reducing fluoride that dentists are always talking about. And the stark white color of the paste? Actually, that comes from titanium oxide, which is extracted from minerals like rutile and ilmenite. And to top it off, the whole shebang gets its signature sparkle from a flaky little mineral called mica.
And you know, it's not just the external products we use either. Minerals are literally keeping us alive from the inside out. Get this, minerals make up only 0.3% of our total nutrient intake. Just 0.3%. It sounds like an incredibly tiny, almost insignificant fraction, doesn't it? Yet they are so unbelievably potent that without this tiny fraction, our bodies couldn't even process the other 99.7% of the food we eat. Basic life processes physically cannot occur without them.
Okay, moving on to Section 2. What exactly are minerals? Let's take a look at how the scientific community actually categorizes these essential building blocks.
To be super precise here, geologists strictly define a mineral as a homogeneous, naturally occurring substance with a definable internal structure. Nature provides them in wildly varied forms, man. I mean, they range from the absolute hardest diamond down to the softest talc.
We can basically split the metallic ones into two main camps. First up, we have ferrous minerals, which contain iron. Take manganese, for example. To put its usage into perspective, nearly 10 kilograms of manganese are needed just to manufacture 1 single ton of steel. On the flip side, we have non-ferrous minerals. These don't contain iron, but they are equally vital to us. Stuff like copper, bauxite, lead, zinc, and of course, gold.
And this brilliantly illustrates the immense importance of non-metallic minerals too. Let's look at mica again. Yep, the exact same mineral giving your toothpaste that morning sparkle. Mica splits into unimaginably thin layers, and because of its excellent dielectric strength, its low power loss, and its incredible resistance to high voltage, it is completely 100% indispensable in our modern electrical and electronic industries. Basically, your favorite gadgets wouldn't even turn on without it.
Which brings us to Section 3, the hidden costs of mining. We need to explore the gritty reality of how we actually extract these materials, because getting them out of the ground, it is no easy feat.
Underground mining operations pose incredibly severe hazards to the workers down there. The constant dust and noxious fumes inhaled by miners make them highly vulnerable to devastating pulmonary diseases. And that's happening alongside the terrifying everyday threats of mine roofs collapsing, sudden inundations of water, and underground fires.
And above ground, the impact is visually staggering. You have this massive machinery being used in open-pit operations to literally carve out the earth. These sprawling sites heavily contaminate local water sources, while the constant dumping of waste and slurry absolutely degrades the surrounding land, destroys the soil, and massively increases stream and river pollution. It's a heavy toll.
In fact, the human and environmental toll is so stark that stricter safety regulations and the rigorous implementation of environmental laws are absolutely essential. Without them, mining risks becoming what the source material explicitly calls a killer industry. We simply cannot power the modern world at the unchecked expense of human lives and fragile ecosystems.
So what do we do? Section 4, conserving our mineral wealth. The absolute crucial point here is that we currently rely heavily on dangerous extraction for resources that are inherently non-renewable.
Because, get this, the total volume of workable mineral deposits makes up an entirely insignificant fraction of the Earth. We're talking merely 1% of the Earth's crust, just 1%. And as global industries continue to boom, we are consuming these finite, precious resources at a remarkably rapid pace. To ensure we actually have a sustainable future, we have to follow a strict, concerted roadmap for conservation. First, we've got to constantly evolve our technologies so we can use low-grade ores at much lower costs. Second, we must aggressively step up our recycling of metals. And third, utilizing scrap metals and developing other substitutes, that just has to become standard practice across all industries. No exceptions.
Section 5. Shifting to renewable energy. Because here's the thing. Conserving the minerals themselves is only half the battle. We also have to dramatically rethink how we generate the energy to process those minerals and run our modern world.
A major shift involves harnessing renewable, non-conventional resources. For instance, India has massive wind power potential. The largest wind farm cluster there is located in Tamil Nadu, stretching all the way from Nagercoil to Madurai. Another really incredible avenue is biogas. By decomposing shrubs, farm waste, and animal or human waste, we can yield a gas that actually boasts a higher thermal efficiency than traditional fuels like kerosene, dung cake, or charcoal. It's a real game changer.
In rural India, these biogas setups are frequently called gobar gas plants because they specifically utilize cattle dung. And they are a perfect example of a sustainable loop. Why? Because they offer twin benefits to the farmer. On one hand, they provide clean, highly efficient energy for the home, and on the other, the byproduct is a significantly improved quality manure for their agricultural fields. Win-win, right?
We've covered a ton of ground today, all the way from the center of the Earth out to the wind farms of Tamil Nadu. So, as you wake up and brush your teeth tomorrow morning, I want you to ask yourself, how many precious minerals are you currently holding in your hand? And what forms of energy were sacrificed to get them there? Keep that curiosity alive, guys, and thanks so much for joining me on this explainer.